Hello, this video I'm going to show you the process to create a 1 Hertz clock for your design, and the targeted board is the DE10 Lite. Okay, the process of creating the 1 Hertz clock is to use components from the library. Okay, so in the library there are components already exist which lets you to use to create a 1 Hertz clock. Okay. On the DE10 Lite, there is a clock source for the board, which is fixed at 50 megahertz. It is really fast, or too fast for any state machines that you want to build. So most of the time, you want to slow down the clock to 1 Hertz, such that you can see the behavior of your state machine. Okay. This 1 Hertz clock is good for you to debug the design on the board. However, it is not ideal speed for you to run simulations in ModelSim. So for simulation purpose, do not include the 1 Hertz clock in your design. If you want to verify the operation in simulations, you should use a faster speed to verify the operation, such as your clock period is 1 microsecond. But if you want to try out the state machine on the board, you should use the 1 Hertz. Okay. So let's create a project to demonstrate this process. File, New Project Wizard. Next, let's save the project in ENGN 2001, hardware, example 2. Next, we need to create this project folder. Yes. Next. Next. Select the right device based on DE10 Lite. Max 10. Device family DA. Pin count 484. Core speed 7. Name 10,000,050. So now you're down to 3 devices only. C7G is the device. Next. Simulation purpose Altera VHDL. Next. Confirm. Finish. Okay. So to see the components to generate the 1 Hertz clock, you need to click View, Windows, IP Catalog. Okay. So let's create one block diagram such that you can put the components required to generate the 1 Hertz clock. New File, New Block Diagram. Okay. Go to the IP Catalog window, expand Basic Functions, expand Clock, expand PLL, ALT PLL. Okay. So this is a component template. Once you put the components into your design, you need to set or configure the parameter. So add, and then you give a name. So by default, we would like to use names that will match your project. For example, EX02 underscore clock VHDL. So now we create a clock for this project based on the ALT-PLL. Okay. So now this is a window to configure the parameter. First, we look at the speed of the device. Our device is C7G, so we'll select 7. The clock source on the DE10 Lite is not 100 megahertz, it's only 50. Okay? Alright. Everything else, default. Next, do you need a reset for this clock generator? No. Do you need a lock output? No. Next. No change. Next. No change. Next. No change. Next. So this is the page where you need to enter the speed. So everything is ratio to 1 megahertz. Okay, so let's try to put 0.01 megahertz. Okay, so you can see that as you're typing in the value, the symbol also changes at the same time. Okay, so this is good. So you look at these values. 0.01 megahertz means that it is equal to 10 kilohertz. Okay, all right. So click next. No change. 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 Next. So here you need to adjust the settings. So the first two checkboxes are fixed. You cannot delete them. You need to select symbol, quarters price symbol file. So it's check, check, uncheck, uncheck, check, uncheck, finish. Okay. Check, check, yes. Okay. So to confirm that, under hierarchy, select files. You should see EX02 underscore clock. That means whatever you just generated, which is a clock, will be added to your project. Okay. Let's return to hierarchy. So we're done with the IP catalog window. You can close it. So now let's click on the symbol tool. Click and check. You can see this component. Click OK. All right. Now looking at the comments on the symbol, the incoming clock is 50 megahertz. You slow it down by a factor of 5,000. So you have 10 kilohertz. So let's do another one of these. So now you can connect between the two clocks. So here is slowed down by 5,000. here is another slowdown by 5,000. So combine them, you are slowing down the clock from 50 megahertz by 5,000 and then another 5,000. So combined is 25 million. Okay. All right. So 25 million means from 50 megahertz to 2 hertz. So this is incoming, this is outgoing, this is 2 hertz. To get 1 hertz, we need to do another one, but in this case, we're only going to do it by a factor of 2. So symbol tools, primitive storage, TFF. Uncheck. Okay. When you look at this video, you have already discussed the application of a TFF. So there's no need to go over the theory again. Okay. So the TFF that we put on is going to slow down the clock by a factor of 2. So factor of 5,000, another factor of 5,000, another factor of 2. Combine all of them, you slow down the clock by factor of 50 million. So it's from 50 million down to 1. So let's rename these components. Let's call this unit number 1, unit number 2, and unit number 3. Okay. All right. We need a pin for the incoming clock. So let's look at pins. Primitive pins, input, connect. We need to have this toggle with TFF to be always toggling. So we need a VCC connection. Other CC, VCC. Okay. We need another VCC to disable the preset. Okay. We need one more pin for the reset. So for reset, we'll always want to use key 0. So input. Right. So this is the reset. This is to VCC and this to VCC. Okay. Let's rename the clock. So on the D10 Lite, there are 2 clocks running at 50 megahertz. The max 10 clock 1 50 or the max 10 clock 2 50. So for this example, let's use max 10 CLK2 underscore 50. Okay. Reset, let's use key 0. So we adjust the graphics, update all the symbols, then you can see that you need to fix the connections. That one fixed, this one fixed. Save your file. This should be the top level design, which consists of all the circuitries, and this should be named as EX02. Add to the file, also add to the project, save. Okay. So if you look at this whole setup, you have 50 megahertz coming in, slow down by U1, slow down by U2, and slow down by U3. So this output Q of the TFF is going to be 1 Hertz. Okay. So when you finish designing your circuits, such as a state machine, you need to connect the Q of the TFF into a state machine so that your state machine can run at 1 Hertz. Okay. If you need 2 Hertz, you can connect the C0 from U2. That will give you 2 Hertz. Okay. Of course, you need to look at the user manual for the DE10 light and find the pins for max 10, clock 250, and the key 0. Okay. If you need different clock speed, you can use the same technique I just demonstrated, but you need to adjust the speed using this clock. Okay. So let's do a file save project. To confirm all the files has been added to the project properly, go to Hierarchy, Files. You should see your block diagram plus the clock component you generated for the project. Okay. So this concludes this tutorial on the process to create a 1 Hertz clock on the DE10 light using library components. Okay. Thank you.